Okay, we're gonna get back on the mold maker. Now, I haven't decided if I want to go the full 15 degrees that I put the head on. Now, I don't know if that equates to 15 degrees here. I haven't measured that yet, but what I want to do is just tilt the head back. But on this one, I was able to leave a nice little chunk in there. I don't know how that's going to work with this one. We'll have to see. I don't know. So I'm going to find a piece of scrap that's long enough, or I'm going to cut one. But we need to raise this thing up. I might double stack some of this stuff in here. Raise it up. We're going to butt it up against this and clamp it down here. And then probably set up another clamp to the side and clamp straight down on this thing, just to give it some rigidity. I am going to leave a gap up front, and then we're just going to come in and work it back until the cutter reaches this tip here. Now, thinking about this now and the angle that I'm going to put on it, I probably would have made this a little bit longer, knowing I was going to cut that material out of there. But this is the first mold of hopefully many, and yeah, we're just going to see how it goes. Shit, I think one spacer will be good. Okay, so I think what I'm going to do is just cut this out with the mill, see how it goes. So I'm going to get some clamps set up. I'm not really sure how to do it. We got our backstop, which is really nice. This will just slide into any one of these grooves. See, it's kind of tight there, and then just slides in there. I'm okay with that. I'm gonna go find a longer piece of this just so we got a full length to clamp onto, and then we're gonna start milling. Okay, this is the sketchiness that we got going on here. We got one clamp holding down real tight here, and then I put this spacer on top. I had to block up these things, but that is tight. I can't move that at all. Hopefully none of this moves. I got it jammed up against this tight, so we should be parallel, so our cuts should be straight. I got this thing on a 15-degree angle, as you can see, and we're just going to start in there and just start coming in on this. That's a lot of material that needs to come out of there. I really should probably plasma cut that, but we'll see if this cutter can do it. Now, I want to show you this. Someone sent me this in the mail, which is freaking awesome. And they sent me some cold chisels, which is freaking awesome. I really do appreciate that. Thank you so much, whoever sent this stuff, man. That's pretty awesome. Now, this Magic Tap, I do have a bunch of this stuff here. Like, I forgot I even have this. I use it for drilling. I really didn't think about putting that in there. I don't think I want to be spraying this stuff. Like, I don't know. I just don't think. I mean, it says it's for drilling, milling, threading, boring, turning, and sawing. But I don't know if I want to mist it in the air. Only because I've already been thinking about, like, if I do start spraying some type of oil out of here, like, I don't want to be breathing oil mist. I don't think that's very healthy. So I'm going to try and, you know, dab this on there, see what happens. But like, I think the mister, even though I am using just water, which I know is probably not giving any type of lubricant to the tool, the mist is keeping it cool. Like, if I just put this on there, I think it's just going to get hot. I don't know. We're going to try this though. I appreciate whoever sent this to me. Improved surface finish, machinability, and tool life. Highly effective on most metals: steel, stainless, Inconel, nickel, bronze, and other alloys. All cut-in operations. Read all warnings on rear label. Let me read this label real quick. Warning: may cause an allergic skin reaction, toxic to aquatic life, with long-lasting effects. Yeah, so I don't know, but let's say for best results, apply lubricant between the cutting tool and the workpiece as needed to maximize speed and feed. Used for all cutting operations on any metal where close tolerances, precise fit, and superior finish is desired. Reapply as needed to dramatically extend tool life and improve machinability. After use of this product, clean and lubricate metal surfaces to avoid staining and or corrosion. Okay. Huh. Avoid breathing vapor. Okay, so I don't think, do not eat, drink, or smoke when using this product. So don't smoke cigarettes or weed when you're using this product. Don't eat sandwiches. Wow, this stuff must be serious stuff. If on skin, wash with plenty of water. Yeah, I don't think I'm going to be spraying this out of that mister. I think there's a special water-based coolant lubricant that you get. I'm going to run a little bit of this, see how it goes. And then if it seems like the tool's getting really hot, I'm going to turn the mister on. Okay, this is where we're at. I had to swap out cutters because this thing, when I put it in there, the end of it looked like a couple of the things had chips in it, and it just got progressively worse. Now, being that I'm cutting steel, there is a formula. I went online and looked to get the feeds and speeds, and basically it's like for mild steel, anywhere from 90 to 100 feet per minute, which means the diameter of this, or whatever, the circumference of this, or whatever it is, you take your size, like you take your feet per minute, you times it by 4, or pi, 3.14 something something. The one guy just said use 4. And then you divide it by the diameter of your cutter to get your speed. So I was around, this is a little bit smaller than this one. I was up around 280, 290 or something like that, maybe even 300. I forget what it was. And it just didn't seem like it was cutting right. And then I was getting sparks, and then I stopped the cutter, and it just these ends are all messed up. So unfortunately, I don't think I can use this at all. I don't know if this can be reground or if this is just trash. But I even got in an area where I wasn't using the bottom and tried to come in on it, and it didn't want to cut. So I don't know if this thing was used or what, but that thing kind of sucked. Now, I switched to this cutter, and I couldn't get it all in one pass. What I'm going to do here is, basically, we got a nice, let me get them chips out of the way. I got to deburr that edge. Where's my file? I can't really get in there now, but I'm going to deburr that edge. And this is what we got. It's going to sit right on there. I pretty much was right there. I came down to about the right. Now I am going to face all the top of this, you know, to make it all even. What I think I'm going to do now, see, we got a nice tight fit, a nice machined fit right there. That's freaking awesome. Now, originally, I really wasn't thinking. I should have made this actually longer, okay? For the amount of width and the depth that I have, once I cut this side, we're gonna have a little stubby ingot, which is fine for now. I'm just, you know, like I said, I'm learning this machine. I'm learning about the melting, the whole process, whatever. This is a learning curve right here. I'm getting the process down. You know, and I'm learning a lot, man. Learning about the feeds and speed. Okay, this is where we're at. So far, I think this thing is actually coming out pretty good. There is a couple things that I don't like. One of them is how short it wind up coming out to be, which is actually okay, but I'm really glad I decided to cut the angles on this because it looks way better with the angles. Like, look at that on the inside, man. When I finish this up and get it, you know, cut all the size, it's gonna look really cool, and it's gonna make really awesome ingots. Where's that? Let me find my ingot. So this is the ingot that Sculler Metals made me. Okay, see that? Sculler Metals. The bottom's a little narrower, but the top's going to be wider. And the bottom, again, is going to be a little shorter, but the top is going to be wider. So we're still going to be somewhere around 8. I'm thinking between 8 and 10 pounds maybe. I don't know how much we're going to get out of the top. I mean, this thing fits inside of here. Let's see. Okay, so this is slightly longer, okay, but you know, we're gonna have that edge, and there's going to be that much more copper. So I was wanting 10-pound ingots, so we might be able to get them out of here. Now I'm going to be, once I pour this, okay, to get it so it doesn't, oh shit, this thing is actually, this little ingot is heavier than it looks. To get it so it doesn't look like this, you know, which isn't bad at all compared to the one I did. And this was just this is my first ingot, so. And yes, I've been reading all the comments. Look at the difference there. So this was a bunch of different, like this had, what did this have in it? Tin coated bus bar and silver coated bus bar, you know. So what I don't like is this stuff here, and you can see it on this here. So what I want to do is have these poured a little oversized, and then I'm going to put them back in this milling machine, and I'm going to face all, this is going to have 1, 2, 3, 4, 6 sides. Sorry, I had to, it's like 3 o'clock in the morning and I'm not firing all cylinders right now. So all 6 sides are going to be faced, okay, so that they're going to be perfect. You're going to be able to run a dial indicator down my ingots and it should be perfect, okay? That's my goal. We're going to have perfect ingots over here. And we're well on our way, man. I mean, this thing is coming together nice. Look at that. Now, I'm not sure after welding this how parallel straight this is, but we're going to check it. We're going to get it down in here. We're going to straighten one edge. We're going to run the dial indicator, get one edge straight, or I think I could just put it in the vise and see how square, straight, everything is. Welding this thing together on that weird angle was, you know, a challenge for one, and I don't know if the weld made anything walk in or out, you know. So it's going to be very interesting to see how close we are, but at least we'll get close enough to where hopefully I could put it on the mill, hog off a bunch of material around the sides, the top and bottom, get it squared, or I don't even know what you would call that. We'll call it ingot, right? And then it'd be perfect, you know? Like, I'm not even going to mill this. I'm keeping this one. This is my first ingot. It's like my baby. It looks like a retarded baby, but, you know, anyway, it's my first ingot. I'm probably going to buff all this stuff out and then put some clear coat on it. I think that's what he did to this. I think he put some clear coat on it or something. But the process. Oh, and one thing, I should have been paying attention to this gauge here, because I went deeper on this one. But it was kind of hard because halfway through, or majority, I pretty much got most of the way through with this bit. It started really not wanting, it was still cutting, but as you can see, it wasn't liking it, okay? Now, I did not burn this up. This thing was already used and had this spinach. It looked like it spun in the collet. These are all used. I have no idea how much wear and tear is actually on these. This one's already, all the little things are cooked off the edge. Now, Steve was telling me we can probably get these reground. Like, this one's really cooked, and I haven't touched this. This was already cooked before me. So I'm using just what the little tiny bits of end mills that I have, which is basically this. That's it. That's literally all I have. I thought this one was going to do better than it did. This one didn't do crap. I made one little cut with it, and the whole time pretty much it was sparking. So this thing was, you know, cooked before I even got it. This looked like it was going to do something impressive, and it just was a disappointment. Although I may have been running it wrong. I did a little bit of research on the RPMs that you need, and it basically goes off of the diameter. So this one, when I put this in, I actually should have retuned checked because it was a smaller one. I probably should have been spinning this a little faster than the big one that I took out, you know. But the process, you know, I'm working on it. I have no idea what I'm doing. I'm just kind of visualizing what I want and trying to get to an end result, okay? The only way I know how, which is basically just start cutting shit. But what I'm gonna do on this next one, these pieces here, I'm going to scribe these, okay? I was gonna try to mill them, like weld it and then mill it. There's really no need for me to mill these side pieces. I'm gonna scribe them where they need to be. I'm gonna plasma cut them, 45 them, weld them in here. I'm gonna 45 the bottom, the top, or the sides, weld them in here, and then just grind. Because I'm running out of end mill, I don't want to burn up anymore because I want to make another one of these. I think I have enough of that stuff, which I don't even know where I got it. Yeah, I got a stack of them there, right? Look at them big ones. Look at the size of the ingots we can make with those. And I got another stack here. So we can make a proper long ingot. So I'm thinking we'll have a stubby little either 8 to 10 pound ingot and then a big boy 20 pounder. And then I'm gonna do something really cool with it on this machine. And I think I'm gonna be able to do it with that rotator. I'm like working it out in my mind, you know. My mind is like, it's like a circus going on in there with all the shit going on that I think about. But I think I can accomplish something really cool with that. And I think you guys are gonna like it, or at least I hope you're gonna like it, because I have a goal that I wanna achieve. You know, I wanna do something with these, and it's gonna be pretty cool. So that being said, I'm gonna wrap this up for tonight. I'm gonna get a game plan for welding this. This is gonna have to be trimmed off. I think I'm just gonna do that with the grinder. I think I'm just gonna grind everything from here out except for the top. And I came in and gouged that. I am gonna fill that with weld and then grind it back. I just want it to look nice. I'm kind of OCD about things that I build. But I mean, look at this. Look at these tolerances, man. Even though I was step cutting down and down and down, we are freaking perfect, man. When that's all welded in there, this is gonna be a cool little mold, man. We're gonna do some cool stuff with this. Okay, this is where we're at. All the welding is done, and except for a little bit of stuff on the top, which I'm gonna put this right back on the mill and clean that up. this thing is done and looking great. Now, my OCD is wanting me to come fill all the little weld things. You know, but this is good as long as this inner edge is nice and clean and tight. I really don't care what the outside looks like. Now, I am on the fence of whether or not I want to put a handle on here. I seen Big Stacked, he had like a couple of these things with a big handle. Probably going to make it easier to deal with, like if I wanted to pour a lot, you know, and use this mold for, you know, multiple ingots in one pour. I'm on the fence with that. I think I might do that. So we'll see how it goes. But for now, I'm super stoked about this. The geometry looks awesome. And now I'm looking at the bottom down there. And on the next one, what I'm gonna do is I'm actually gonna face all of these inside parts because I want the outer finish of these things to look as good as possible. Or I might just see how this comes out. If I'm gonna put it on the milling machine anyway, it really doesn't matter. But now I'm thinking about how I'm gonna fixture an ingot. I could see fixturing it upside down, okay? Easily I can clamp, you know, this side and this side with like a little thing. I'm gonna have to build some custom jaws to lock onto the end, like some, I don't know, some type of soft jaw so I don't mar up the copper, but still gonna grab it because we have to be able to face the sides, you know, and the top, as well as this is gonna be the tough part, is facing the top. How do you run a face across the top of this? Now, if I was doing metal ingots, I could just build a magnetic base, which I think I actually have some magnetics. You have probably already seen them in some old videos back at my old house from some security doors. I have some huge magnetic electromagnets, and I think I could use them to build like an electromagnet thing for the milling machine. So I could just put this part on here and face this off. Because what I'm gonna have to do with this now is I'm gonna have to put a bar across one side and face all of this, flip it, put the bar on the other side and face it, and hopefully the bar doesn't mar up. Well, I mean, it doesn't matter, it's gonna get banged up anyway, but anyway, I'm gonna get this set up on the mill, and then we're gonna turn this down and we're ready to pour some ingots. Steve went over here and cracked a whole bunch of fins off of, I'm gonna sweep up all this little aluminum. It's all the fins from this, which I think is gonna make for some good meltage. Way easier than that other bull crap that I was melting before. And I'm gonna set this thing up either right outside or over there on the floor. And then we're gonna pour a big old ingot. I'm gonna try to get as much as possible. I don't know if I'm gonna do it tonight because I am going to, I got some flat bar over there. I'm going to make some type of holder for this, you know, because this thing already, a notch fell off there. So look, it's already falling apart. One pour, two pours, this thing is, I'm not too confident in that one. These ones here I bought, these were a little bit more money, but I don't know, why couldn't I use metal crucibles? Why do they gotta be whatever this stuff is? Okay, so this is what we got going on here. I got this thing butted up against the back stuff. That really doesn't matter. What really matters is the up and down. So what I did is I found what I'm gonna call the lowest spot. We're gonna mill that until we get, you know, it all cleaned up. We're gonna zero this so we know where we are up and down, because we might have to take more than one pass. And what I was originally gonna do is like mill half of this and then flip it, but this bar is long enough and I think it's gonna hold it tight enough to where I could mill this side, mill this side, flip it like this way, and then mill these long ways. I did have to bring this out from 3 inches to 8 inches so we weren't banging into the back over there to get this thing, you know, out far enough. So I got this 4-flute high-speed steel. I don't know how it's gonna go. That last one that I was using, which I think was this one, it seemed like towards the end it really wasn't wanting to cut, you know. And these, like I said, these things were used. This one here didn't want to cut either. I think these can be resharpened, and I'm going to explore that. This thing actually came out great. I kind of got a little deep there, but I didn't want to mill more than I had to. It already came out pretty good. Now, you know, there is a couple weld spots where I knew it was gonna come through, and I actually was going to 45 this or chamfer it on the mill, but the weld, I noticed the weld is what probably messed up that high-speed steel, and even that carbide didn't like cutting through that weld. So I didn't want to burn up any more bits. We are running low, and I actually turned the feed down. You know, I'm getting conflicted information. One person's telling me crank it up, the other person's telling me run it slow. The internet, I did some things on the internet. It said run it slow for steel, you know, so I slowed it down. It seemed like it did okay, but I am noticing, man, there is like some imperfections in the plates. I'm really wishing I would have faced all this stuff first, but you know what? This is my first one. It's a learning curve. The next one, which is going to be bigger, we're going to do all that. But for now, what I'm going to do is just file with a light file, just any burrs. I want that inside edge nice and sharp. But I don't want to get cut. That mill did leave a really sharp edge on there. So we want to deburr this thing. And yes, I know files only cut in one direction. Really nice. So ultimately what I want to do is make an ingot to where I can pour it and know how much I'm going to need to take off. You know, a couple thousandths on the mill to get it to be an exact weight. Could have went a little deeper, but I don't want to take off too much material. Like I said, this is the first one. The next one's going to be a little bigger, and I'm going to make it more precise. So what I want to do is actually put this like in the machine and then run a dial indicator across this. It looks like at some point someone was hammering this plate, so there's going to be an indentation there. I should have picked better plates, or like I said, we're just going to face them off. That way our inside is perfect. As it is right now, I'm going to say this is a very nice, precise ingot for my first one. Okay. The first mold. She's going to be a biggin. She look nice too. I think I am going to weld something on here so that I can flip this. Also, what I'm thinking in the future, so that I maintain this nice edge on the inside, I'm actually going to step cut this. I'm going to leave a couple thousandths, maybe even a quarter inch, all the way around. That way if I flip this over and bang it on the ground, it's not going to affect this inner lip, you know. So the next one we're going to make a little better, but for now I think this came out awesome for my first ingot maker. This is going to be a nice chunk of copper or aluminum. Tomorrow we're going to start off by melting some of this aluminum. Yeah, that looks nice. I love the look of the milled finish. Now ultimately I wish I could have ran this in one shot, and we are going to be exploring a magnetic vise. I think I actually have electromagnets around here somewhere that would be strong enough to hold this in place, as long as like I butt it up against my thing, mag it down, and then just run a couple thou at a time. I wasn't taking much off. I'm gonna have to look into you know, why that cutter was not liking them welds. I guess it's because it's hardened or whatever. But we don't want to burn through a bunch of cutters. But overall, man, this thing is nice. So if you come this far, thanks for watching. Leave a comment, let me know what you think. Any suggestions? Should I put a handle on there? I probably will, but let me know what you think about that. Let me know what you think about putting a lip around here to protect this inner edge. And let me know how much you think this is going to hold in aluminum and how much you think it's going to hold in copper. I think it's going to be like a 10-pound copper bar. And then the ones I want to make next are going to be bigger than this. We're going full-blown big boy ingots over here. So for me to do that, I'm going to have to step my crucible game up, because these little crucibles, I don't even think are going to fill that one. This one might. This is a big boy. I need to step my my furnace game up, because yeah, that's not fitting. So this is what we need to be melting. This little stuff here is you know, this is entry-level shit. We're looking for this and bigger. Like this to me is not even enough for what I want to do. So we're gonna have to definitely step it up. I actually, what's crazy is, I was thinking about taking that incinerator apart, and I've been getting calls on it. People interested in it, but I don't know. I'd rather keep it for myself and gut it and use the burners to make a badass, something big, something I can melt like a 5-gallon bucket size worth of copper at a time, and pour some serious ingots and get a lot done at once. So let me know what you think about that, and we'll see you tomorrow. I'll tell you where we're going, right to the scrap yard. Watch it. Look, it's dancing. You ever seen your copper dance before?